Hello, this is David Hall, and it is my pleasure to welcome you all to today's webinar presented by the IoT M2M Council and sponsored by PTC. Since its establishment 2 years ago by 20 high-profile organizations, over 20,000 adopter members have joined the IoT M2M Council, which has focused on making the implementation of IoT and M2M solutions simpler, faster, and more profitable for its member base. If you are not a member, please consider joining by applying on our website, iotm2mcouncil.org. Before we start, there are a few items that I would like to bring to the attention of our viewers. Today's presentation will be approximately 40 minutes long, followed by a 20-minute Q&A session. This is an interactive webinar, so we are eager to receive your questions at any time. Just type them into the Q&A window on your screen. Our panelists will address as many of the questions as possible during the Q&A segment following the presentations. Please address your questions to all panelists, which is the default setting in the Q&A box. This presentation will be archived and available for viewing later on in the events section of the IoT M2M Council website. Now, before we get started, we do have a polling question I'd like to see your response to. And that question is, how soon are you seeking to have your smart city or energy project go live? And you should see on the bottom right-hand side of your screen the opportunity to make your selection. And while you do that, it is my pleasure to introduce our presenters, Scott McCarley of PTC and Mark Schreiber of DEPsys. Scott is Senior Director of Smart City Solution Management at PTC, where he is focused on smart cities, which includes power, water, buildings, and city services. For the past 3 years, Scott has worked with ThingWorx, partners and customers in the city space as part of the ThingWorx product management and solution management teams. Scott has over 15 years of software management experience in roles ranging from software development to leading marketing departments. Scott holds an MBA in marketing and strategy from Carnegie Mellon and a BA from Colby College. Mark is the leading director at DEPsys with degrees in engineering and business administration. Mark started his career in embedded software development before going into training and ultimately sales and marketing, where he has telecommunications and IT. Where he has spent 12 years, and Mark has worked in various industries such as industrial robotics and machine tools, telecommunications, and IT. He is now the Director of Marketing and Sales at DEPsys, a company developing solutions to bring intelligence into traditional electrical distribution grids. I will now hand the session over to Scott to start the presentations. Scott?
All right. Well, thank you very much, David. And Mark, thank you for also joining us today. Thank you all for logging in as well. So as you know, the energy market is rapidly transforming. There's growing city populations, rising energy consumption among those populations, aging infrastructure, new forms of energy production and renewables. As a result, you're likely considering some technology, potentially IoT purchases to address these changes. And today, I want to provide you with an outline to both enable you to quickly meet your immediate technology needs, delivering IoT solutions that rapidly deliver an ROI for your immediate issues or your immediate projects, but also to put you on a path and enable you to meet your long-term strategic goals to develop new revenue streams, new innovations, and to become a leader or to stay a leader for years to come. So just a little bit of background information. ThingWorx is an IoT platform. So our platform and ecosystem enable the creation or rapid creation of game-changing IoT applications, citywide platforms. ThingWorx is part of PTC, so PTC is the business. PTC is made up of over 6,000 employees. Within the ThingWorx platform group, we have over 800 employees dedicated to creating our IoT platform. So it's a huge amount of investment. As you see, that it's on the back of over $1 billion in investment in acquisitions and organic development. There are thousands of ThingWorx and ThingWorx compatible partners and solutions in the market today. So with that, let me just, I mentioned market transformation. So there have been enormous changes in the grid and the energy market. today, in addition to growing populations, we're seeing fewer fixed generation power plants, really, moving away from nuclear, moving towards increased renewable production. So whether that's wind, solar, could even be water, tidal. There are new forms of energy storage, and that could be batteries inside of cars, batteries in buildings, all sorts of methods to store energy. And there are many new sustainability goals driven by municipalities, driven by consumers. So energy is rapidly transforming here. Okay, and also I'd mention that the market itself, depending on where you are geographically, is experiencing rules and regulatory changes. So your business or an energy business who might be your customer is being forced to exit some of their markets, and as a result might be looking for new revenue streams or figuring out how can they be the leader that they want to be with these new rules. Across all of the market, I think we can distill many of the common goals. So there are many players operating at many different points within the market. Some of the real, the high-level goals for businesses and participating in this market are grid stability, right? So that is at the priority concern. And we'll hear from DEPsys, shortly about their wonderful solutions to ensure grid stability and deliver other value as well. But grid stability is tantamount to companies participating in the energy market. They're also all interested in reducing the costs of their services, whether that's sending service personnel to look at the lines, to pull information from a meter, to service the equipment within a generation plant. So anytime you're offering a service, companies want to understand how can we do that more cost effectively? How can we scale that service to deliver to new markets or to offer new services but at a lower cost? One of the methods that they're looking to enable new services, to enable new efficiencies, is through better communications. And that communications could be from the consumer, meaning the sort of at the meter end of things, the actual house consuming, or a business, to all of their employees as well, who traditionally may not have had mobile communication. So communications is an important part of their goals. And these businesses in the energy market, as many of you may be experiencing, are often looking to develop new revenue streams, right? And as we see this market transformation, it introduces a number of challenges, but it also introduces a number of opportunities. And so many businesses are looking to enter into adjacent markets or to leverage their existing investments to bring forth new revenue streams. And there is significant opportunity to do so. So how is IoT addressing some of these energy market challenges? Well, I thought I'd talk through a few and just mention a few partners who are involved in the space and just giving some examples. So it starts at the centralized generation, right? So IoT within a fixed generation plant, or if you're a power provider, you might have multiple plants, and within a plant you might have multiple pieces of equipment that are producing energy, but right now their production information is often contained in different solutions. So these types of, could be utility that's producing energy, or trying to bring all of their production data into one solution, right? So they can see in one screen and how much is this plant producing? How much energy have I committed to produce? I have service level agreements with businesses who have committed to provide a certain amount of power. How is my production matching these commitments? And to do so from one screen and be able to compare plant to plant to really identify where are the immediate issues and which plants are maybe underperforming and which are performing quite well. So that's centralized generation. There's activities there. A partner of ThingWorx, CVM Technology, that has a nice solution in that space. In smart grid operations, there's a lot going on. DEPsys is going to spend some significant time talking about this today. But being able to really ensure that that the production and consumption, the voltage and variance, are being met or being maintained throughout the operations or throughout the distribution and transmission of energy is key. Inside of distributed, so the renewables, there are new solar panels going on top of all homes across the world, or many homes, and the ability to monitor, control, manage this equipment, provide that information, insight into, share it with the other ecosystems or the energy ecosystem, that information, how that energy is being introduced back into the grid, providing information to the operator of that equipment. So, that's a key piece of the challenge as well. And businesses like partners like Itron are delivering solutions in this space, or our partners like Itron. And on the meter end of things, there are, obviously every home has a meter, and there's a lot of new opportunities and new programs that you can associate with the meter. These meters also provide communication networks, across a city, across, large geographic areas. And these networks can be leveraged to do great new things as well, deliver new solutions. And, we're excited to be working with companies like Census in this area too. So as we, one important, sort of element to keep in mind, we spoke about this just a few minutes ago, but as you deliver a solution, it is part of a system, right? Solutions don't exist on their own. Systems, they feed into a system, and that system delivers more value, and that system may even participate in a larger system. So, this example here is of lighting, and this is meant to walk through, as you have a project that IoT is likely part of, you want to think about, how is this project, what other systems or what other connected assets does this involve, and what other adjacent systems does this impact? What additional value could we find there? So just use an example of lighting, right? So, everyone's familiar with this example, so it's a nice sort of starting point. You have a light, first we added, embedded software and controllers to be able to, control it, made it a smart asset. Then we added connectivity, and now we can remotely manage this and very intelligently manage and, adapt lighting to deliver very, great municipal solution. But that lighting, that connected lighting isn't just a singular asset, operating on its own. It's become part of a connected system, right? So now we have cameras on the lights that leverage that same backhaul communication infrastructure. So however that light is communicating information to a server, potentially in the cloud or on premise in a city or in a utility, but it is communicating information. And now we're also communicating information that we might have detected via camera about parking availability, sound information, about safety information, gunshot detection, as well as information about traffic flow patterns. So that connected asset is now part of a connected sort of infrastructure system. And you can extend that further. And this is really the system of systems perspective. And smart grids participate in a system of system. And I would call that system of systems really a smart city. There is an enormous overlap between the sort of core systems of city infrastructure or transportation, buildings, the grid, and then also water, right? So if you're a building, you might have a large battery, right, associated, or if you're a large complex of buildings, you might have a battery storage, and obviously that's a key participant to the grid. Consumers might also, right, be generating information inside of their buildings and participating back into the grid. Those same buildings have water reclamation, infrastructure. There's a tie between flooding and flooding that might be indicated from a piece of city infrastructure through the water system to see the sort of severity of it, back to the grid to show where this could be impacting and how you might react best. So there is truly a system of systems at play, and I encourage you to think about that as you think of building out your sort of technology vision and your vision of your strategic goals for your companies. And just to make that point, McKinsey throws out a very nice, incredibly large, it's exciting $1.7 trillion in new economic value created by IoT for cities. Much of that is around energy, but what is more important or what I wanted to illustrate here is that much of that new economic value is a result of system interoperability, right? So being able to receive new sensor information about something in the field, combine that with some system information that you might have elsewhere, and potentially bring in other information sources as well. Combining that all together delivers new insights and new value. So where do companies start? Right? If you're a utility, you have a lot of challenges. If you're, whomever you are, there are probably multiple projects you're considering. You can see the potential value in all of them, but you need to determine, where do I start first, and how do I start, and how do I do so intelligently? Well, today, most people take, or many people take, a tactical approach, right, where they seek to deliver a point solution. For example, they may want production visibility into a renewable asset. They may need it. And so they would go about building a solution to deliver that visibility. And if they take this sort of tactical one project approach, there are a lot of downsides, and you're bearing the entire cost of transmission, storage, and the server environment on this one solution. If you keep doing tactical solutions, each one comes with new infrastructure. You keep recreating sort of the plumbing, the IoT plumbing, the features like how do I speak different protocols, how do I bidirectionally communicate to an asset. So a lot of the plumbing technology gets recreated if you take this tactical approach. But maybe most importantly is you can't reuse code, and you can't share development efforts across solutions, particularly as you seek to bring and break down silos, right? So you're going to want to combine information from multiple sources here. And if you have a ton of architectures in place, obviously there are increased risks of architecture failing at scale, security. It just becomes hard to manage those things, and it becomes hard to keep up with innovation, right? So you need to push innovation into all of these solutions. The alternative approach would be to leverage a platform, right? And so a platform offers some real strategic benefits, right? If you look at each solution as a component of a holistic system, you can drive a lot better outcomes. And that's really being able to leverage existing investments for any of the individual solutions across the whole system. So that could be that backhaul connectivity. It could be the cloud infrastructure. It could be the physical asset itself, right? You can iterate. So anytime you're deploying a solution in this market, in a rapidly changing market such as this, I would expect there to be some iteration. And really platforms are designed for that rapid evolution, being able to rapidly create new sort of business logic, features, functions, forward-facing, but see what works and then evolve from it. And ultimately, you're going to be able to share development efforts across all solutions with a common security and scalability platform underneath of it. And you can open up your efforts to an ecosystem of third-party businesses who can also add new efforts and solutions into what you're doing. And then finally, a platform is wonderful at providing new innovations, but maybe you weren't, you had no efforts in sort of, or no programs in place to even explore things like augmented reality and anomaly detection or predictive analytics, right? So a lot of these key capabilities that are delivered through a platform can become parts of your solutions if you leverage them. So with ThingWorx, how do our partners engage with us? Well, there's a couple ways, right? So our platform and ecosystem can, enable the rapid delivery of solutions with any of these combination of the following on one infrastructure, right? So you could work with some of our partners who have created out-of-the-box solutions based on ThingWorx for a specific market challenge. It's very much an out-of-the-box solution for a challenge, and these are ThingWorx solution providers, and we're very happy to work with DEPsys in this manner, where they've created a fantastic solution. Second way is that you can yourself use the platform to build your own solutions, right? To connect assets, break down information silos, and leverage IoT to meet meet your own and your customers' unique needs. And then finally, you can in fact deliver the platform to your ecosystem to help them, build new solutions, leveraging maybe some of your existing investments to deliver new value. So those are the three ways. And let me just quickly, give you just some examples. We are working with great solution providers across a wide array of businesses, whether it's in water like Aquamatics, DEPsys, whom I've mentioned, Wise Up, who has a wonderful building energy management solution. And these are just examples. And all traffic and variable traffic signage inside of cities for transportation, smart lighting solutions with providers like Synapse, fleet management solutions with partners like CenturyLink. So there are a number of out-of-the-box solutions, as well as the capabilities for you to build your own new solutions leveraging the platform. And so some of the core capabilities that the platform delivers for people interested in building new solutions themselves, or perhaps with other partners helping them is through, like a system integrator. You can connect to any device, leveraging any protocol across any network, deploying solutions to, different device clouds, could be, Amazon, Web Services, Microsoft Azure, could be an on-premise solution of yours. So we're going to be able to enable you to quickly connect, send information to the cloud or on-premise location of your choice. Going to enable you to quickly model, so build a digital representation of the physical world and the systems that you're going to be pulling information from. So quickly create a model, and then through drag and drop methods, create a UI very quickly so that you can focus on the business logic, delivering solving the business challenge, and leave a lot of these, kind of what we'll call IoT plumbing issues to the platform. Through the platform, you'll also receive new innovations. So if you built a mobile app or a web screen displaying digital information, well, why don't you also deliver that in an augmented reality experience, right? So you'd have the potential to do that, so that if you were looking at a piece of potential grid infrastructure, you could see right through your phone, just looking at the physical view of it, see the overlay of digital information. And through the platform also, we've had proven scale, robustness, and security. And you can rest assured that those are concerns, and that's our business. We understand this market quite well. So there is a lot of reliability or security that we can provide you as a potential solution deliverer or user. So finally, I kind of talked a little bit about augmented reality. I'll just mention it again because it's so fun, and I do think it's something coming, right? And so augmented reality is just an exciting way to provide interface to look at the real world. Everyone has a phone with them. They might have a tablet. In the future, they might be wearing wearable glasses. And you could look at the physical world and overlay digital information. And there's a lot of potential ways it could be used, providing interfaces to things that don't previously exist, like a meter that might not have an actual gauge, but you could get a digital gauge, to grid infrastructure, where you might overlay sort of a heat map, show where heat is through a sensor, where it's heat, through where infrastructure is underground. There's certainly a lot of lines underground. Where is that? So showing the diagram of it. So a lot of excitement here, or providing work instructions on how to address a facility. There's so much there. It's super exciting. It's fun stuff. But I want to emphasize that the platform is a mechanism for you to deliver both near-term solutions, but also to put yourself in a strategic roadmap to deliver new innovations and future values, develop those new revenue streams, and solve today and tomorrow's problems. With that, I'm going to turn it over to Mark Schreiber. I look forward to answering any questions at the end of the webcast. Thank you.
Thanks, Scott, and a warm welcome from my side. Let me walk you through smart grid is more of a buzzword in the marketing term rather than a precise technical definition. Is really smart, and how smart can it really get? What grid operators need? Visibility, stability, supply security, and then the future is in energy efficiency, because all this nicely generated energy, you want to use it and not waste it. So a little bit of a context here. the energy transition means we want to step out of nuclear and fossil energy and step towards renewables. So all this renewable energy paired with future electromobility is putting or creating instability in the grid. And here is where our solution called GridEye is actually stepping in. So the challenges we have here is that before production was centralized and very predictable. Now we're in the new world, the renewable world. It's decentralized and very unpredictable because we don't know when the wind blows. We know when the sun shines, usually during the day and not during the night, but there might be clouds and then the production is not so big. So this is where we step in to manage all that. So we see here a typical area where we installed some measurement modules, and what we could see is that on a sunny day, the voltage goes easily up 9% in this particular area. And you perhaps know that voltage stability means that grid operators have to write to deliver voltages of plus or minus 10%. So we are coming very close to the limit here. And at the bottom graph, we see here on a cloudy day that the variations are very high as well. So 10 volts plus, 10 volts minus. So what does that mean for your electric systems, your TV set you put in your power plug? You probably won't like it if it receives 280 volts instead of 230. So this is where GridEye steps in with first real-time monitoring, because we were talking about visibility. So grid operators want to know what's happening in their grid. So far, they have no visibility. At the very bottom of this list, there's control of distributed energy resources. So if we need to do control to re-stabilize the grid, we can act on the energy resources. We can also act on loads. There are controllable loads. And in the middle between the two, we have the storage systems. Might be a battery, local battery, area battery, or it can be electric e-mobility, because as well, sometimes it's a load, sometimes it's a source. And the beauty of this solution, where you see here the interface, but also the hardware, the measurement and control hardware, it's installed very quickly, 20 minutes, and plug and play, then you can go, and it's fully remote controlled. So no need to intervene in the field. This picture here shows pretty well where it applies and what it does. So we have this module here in the transformer station. Transformer station to monitor voltage, current, power, and we can even control the transformer if we have a tap changer here, which is a controllable transformer. And a little bit further downstreams, we have the distribution cabinets where you also monitor. You always have a small picture on how this is mounted. And where we have the big production here, example with a PV on the rooftop, in inverters here, where we monitor as well and can here control active and reactive power. What is not shown here are the batteries, the storage systems, and the loads. But this is as well controlled. So in a very small form factor, we have here measurement, monitoring, control, and communication between all the systems. And looking at this picture here, with GridEye, any grid can become smart. But that's nice. We all want to become smart, the grids as well. Why are we telling you this? Just because we have a model-less approach, meaning that we don't need to know the exact model or exact configuration of the grid. And if we look at the picture here, we see and we understand why it's impossible to work with models, because in places like this one, nobody knows where the lines are, how long the lines are, how old the lines are. So it's virtually impossible to have an exact model of that one. So we were talking installation before, 20 minutes. So here you see one of our technicians of the grid operator installing that in a distribution cabinet, very small form factor, and you can plug that directly without power interruptions, without additional power supply. No need to have specific skills, no need of parameters to fill in, and in 20 minutes it's up and running and delivering the first results to the backend system. Talking about backend system is our server. We see here on the left the current interface that we have. I put in another picture to the right. This was our first interface, where actually the original ThingWorks interface library that we used to build that one for the graphs. It's actually pretty nice, but we still felt that we should have a personalized interface for our solution. And you see here on the three pictures the map where we can show where all the modules are. Then you see the graphs for voltage, current, and power. You see some statistics with transformer load distribution, things like that. So everything has been built based on ThingWorks with a very powerful library of graphical components that you could just drag and drop. This saves us a lot of resources and allows us to react very quickly to customer requests. So we can also develop rapidly personalized, customized screens for our customers without any issue. So this is one of the strengths that we experience here from ThingWorks. Other thing is about communication, but that's basically what you understand when you hear IoT. So you think communication. To the left here, a small drawing of the grid. The two circles, that's a transformer for the ones who are not familiar with electricity. So you have the high voltage, then transforming down to medium voltage, transforming down to low voltage, and this is where we apply. We have all these grid-eye modules here, the blue circles, that all communicate with each other with different protocols like GSM, power line, radio frequency, or can also be fiber. And they also communicate then, you see it with the red arrows, with our backend system, which is called here Grid-Eye Server, but it's nothing else than a visualization system, a data management system. So the whole intelligence is actually in the Grid-Eye modules in the field. Different protocols are supported here, but this as well saves us quite a number of resources using the IoT platform from ThingWorks, because we don't have to care about the communication. We just include a library in the Grid-Eye modules and can then just put in data and files and send them over to wherever we want, to one of the modules or to the server, and we are sure that it gets to the other end. So that's very pretty convenient. Also, the work we do with ThingWorks. I mean, I've been talking to our ThingWorks developer here, and he's very amazed from the very reactive support, because he's in touch with them very often and gets a lot of support to better develop that system. Okay, what I still have here, also some analysis based on the measurements we have, voltage measurement, current, energy, power. When we actually store all that data, because we send one set of data every 10 minutes to our backend system, and when we accumulate that through 1 month, 1 year, we have actually possibility to have big statistics, and this helps us doing additional functionality like grid analytics, grid statistics. You have some examples to the right. What's the distribution of the transformer loads? What's the power flow direction? What's the balance between the three phases of the electricity? Or are they in balance, or are they out of balance? So this is what you can show when you store and then calculate and show these analytical graphs. So that's another application on top of just monitoring, control, stabilization, possibility to build a lot of different solutions, like help for network planning, asset management, and things like that. Okay, so that's it from my side. This wraps up the story. So our system is basically a real-time system for measurement, monitoring, stabilization, and optimization of the electrical grid. And we stabilize the grid and looking into energy transition for the future. Okay, with that, I think I hand it back to Scott.
All right. Thank you, Mark, and fantastic presentation, and thank you for dialing back in. That was wonderful. Really great presentation. So I have here in front of me a whole list of questions. Just a reminder to the audience, if you have additional questions, please continue to send them in. I'll go through some of these now. So let's see here. Some of these I think were probably addressed as we through the presentation content, but I'll start with this one. And this is for you, Mark. So will this be installed in every house? So in reference to DEPsys.
The answer is no, because we are really focused on the grid. That's why we saying we're doing smart grid and not smart home. So we deliver a tool to the grid operator and not to the private person. So no, it's not in every house. It's probably a little bit expensive for each house owner. Technology-wise, it would be possible. I mean, no problem. But also, we have to know that if somebody has, 6 square meter of solar panel on his rooftop, or a small car, doesn't really have a big influence on the network. So where we might be is with big productions. If you have a big farmer with a big rooftop and something like 200 kilowatt of energy production, that might be interesting, because this is where you have a big installation and a big impact on the network.
Okay, makes sense. And this question, I think, is, as you just defined the installation, I think this one makes sense. So how many measurement modules do you need in an installation, so in the network?
So we have actually a scalable product. We can actually get along with one single module, but that really depends on the area where we're in. We say we place a module, obviously where we have something to control, because no module, no control. But for the measurement, we measure all critical points. Now, the next question would be, what are the critical points? So, as I explained before, okay, if you have a big production which is injecting power into the grid, you might expect that voltage can go up and you have other problems. If it's just a small production, no impact, so you basically don't need any control, any monitoring there. So it really depends on how many big producers or how many big consumers you have. So because if in the future everybody is a Tesla, that might be a big problem as well.
All right, great, thanks, Mark. So I think this next question's dedicated or directed towards the platform. So maybe I'll answer it, but Mark, if you have any additional comments, welcome it as well. And it says, what LPWAN connectivity technologies like LoRaWAN, Sigfox, Zigbee are supported in the platform? And the answer is we can support all of them and do. We're agnostic really about the connectivity type. So we are, partners with Sigfox. You can communicate via Zigbee or LoRaWAN. They are all, they work with the platform, meaning if you have information that you're trying to communicate, we can communicate that information via different protocols, via different connectivity networks. So really all of those are supported. Mark, I don't know if you have anything to add from DEPsys side about that, or
not really. No, that's
okay. Yeah, you didn't need to just welcome any. So this next question is it's directed to you, Mark. In terms of value prop for a business, is the ability to better negotiate usage discounts, so specific to knowing peak usage times, etc.
Well, what we have been discussing so far is essentially the technological part of the solution. But of course, this is not the only part. There is a business part. There is a regulatory part. There are different pieces to the equation. And currently, I don't think the market is so settled that everybody would agree on how these things can contribute. So I think currently every utility will have to find its field of application, and we'll see where they can make better business. And I think the businesses as well, by including the customers, the end customers, into that system. I mean, the old system where you just had a production and you sell a number of kilowatt hours is probably over. You will have to find some other things. And also in terms of financing, we say, okay, I'm a utility, I finance, 20 or 30% of your installation, but you give me access to your system so I can use that for to stabilize my grid or to store energy and to resell energy later, things like that. So, I mean, that will be the negotiations that will go on in the future. But there is not one single business model that I would see today. But today is also something. Yeah, go ahead.
No, Mark, I did not mean to interrupt. Sorry.
No, it's also for the grid operator a big potential for savings, because his mission was to accommodate for all the consumers and all the producers, and this is probably not possible anymore because you have these big peaks. And if he can now shave these peaks, put that energy into some type of storage, and doesn't have to reinforce its grid for just something like 3% of the time. This would be a big waste of money. So he can save his investment cost, and can also participate in the energy markets with the storage systems.
And to clarify, Mark, so your customer today is the grid operator. Is that correct?
Correct.
And I agree entirely with what you're saying. There is, and with a person who asked the question, or at least there is a large value prop for a business in the future. Particularly as they bring on, as you were mentioning, those batteries or their existing consumption. If they have a tight handle and can shift their energy consumption, there is real value in terms of being able to negotiate with the operator or energy provider. So there are, I think that's an exciting area. And if you're a large energy consumer and there are, I would see a real evolution. I think, businesses today may not have a tight handle on their energy consumption, patterns. How much do they consume across which buildings? When do they expect to consume, energy? Where are their efficiency opportunities, and as the question here is, when are there opportunities to shift their energy consumption to negotiate better potential rates with the utility? And that is a real opportunity. Go ahead, Mark.
And you can make your system even smarter. I mean, why should you use your energy or buy expensive energy today if you know that tomorrow the sun will be shining and you will have the full day to fill your battery? So you can connect then your system to meteorological forecasts so that you know will be cloudy or sunny today, and this might change the action you take on your consumption or energy shift. The same thing is you can analyze your behavior and predict future behavior based on that, because if you have experience on what happened in the past when that situation occurred, you can basically estimate that if tomorrow that same situation occurs again, the reaction will probably be the same. So you can influence your actions based on that as well.
Absolutely, yeah, and we see such an exciting opportunity area in that space, and I suspect you and I, Mark, could talk for a long time on that issue. Let me find another question here. Okay, there was. Let's see. Sorry, I apologize. How can IoT help in anomaly image detection? So maybe I'll answer this in anomaly detection, and really how I'll speak to a use case in anomaly detection that we see frequently, and it's with the assets in field. So, for example, if you have it could be a transformer, or it could be a piece of equipment in field that you're essentially just running local analytics on to detect what normal behavior is. So machine learning to learn what are the normal signatures of normal operation for that piece of equipment, and when something anomalous occurs, as detected by machine learning algorithms, just to alert and take potential action based upon sort of the defined business rules. So that is how we see anomaly detection working, where you're just listening to reading sensor values and information coming off of the equipment to determining what is normal operating, what normal operations look like. And then anytime there is deviation from that, and again, this is machine learning, so it's constantly relearning if it was or was not an anomalous situation, and will improve that understanding. But that is in heart what anomaly detection is or a use case for through our platform. And what we've sought to do is to try and make that as easy as possible, so that if you're configuring, if you're receiving rich information from an asset, you can simply, check a box to say, I want to watch this asset for anomaly, detection. Alert me when you detect an anomaly, and potentially take these autonomous, actions as well. Call a service rep, do whatever it is you need to do because of that. So that's what anomaly detection means to us here.
And that's good. That's great, Scott. We should talk together, because we are currently trying to implement fault detection in our system. If you have any solution for that, let me know. But basically, it's really observing what we have, but the difficulty here is defining what normal and what anomaly means. So if the voltage goes down by I don't know, 20 volts. Is that normal or is it not normal? In which case is it? In which case it's not? It's not that simple. You cannot just put in a threshold and then you can pull an action. It's unfortunately not that simple. So, but yes, basically you're right.
Yeah, and I agree that you need to go through some significant learning process around, looking at values of data that have been flagged as normal behavior, and as well as understanding and appreciating, detecting correctly anomalous behavior. So I think maybe one more question here for before we hit the 12 o'clock hour. Let me see what I can find in here. And there are, if there are any questions that get asked that come up later, we'll certainly respond via, via email. So we look forward to following up. I apologize. There was a question regarding the security, which is, a large topic, and David, the webinar host, shared it with me. Okay, what security is provided? It's a big topic. We from a platform perspective have webinars on security, right? So I would encourage you to delve into those, and I don't want to minimize it, right, in a 1 minute answer, but I don't want to ignore your question either. So please check out the, from the ThingWorx website. We'll follow up with you and share that link. But if anyone has security questions, there's wonderful security webinars. I think some of the things you want to do, right, are you have assets and fields. One aspect of security that I think is important is the device-initiated communication, right? So that's a part of the architecture that we're, in things like encryption, authentication, privileges are all really important and are all, core elements of the platform. The one element, though, that I think that sometimes people don't think about is how does, you want the device to be initiating communications with the server that, ultimately it's communicating to. So there is only one server it may talk to. And that minimizes sort of the attack surface of, someone trying to errantly communicate, or not errantly, I should say, and sort of nefariously communicate with a server to try and get it to send information back. So as long as we, kind of through architecture have the device initiate the protocol and only with one server, or initiate the communication and with only one server instance, I mean, that is a great piece of security architecture. Mark, I want to thank you personally for a wonderful presentation. David, I'll turn it back to you at the hour here. Thank you for hosting it, and look forward to answering any questions over email. Thank you again. David?
Yes, on behalf of the IMC, thank you, Scott and Mark, and thank you all for joining us today. A recording of today's webinar will be available in the next 48 hours on our website, iotm2mcouncil.org. You will receive a post-event email which will include information on the recording as well. Thank you all.